All right, so in this chapter, we'll be going over the different types of hydraulic valves, and then we'll talk about mostly the operation and how it works, some advantages and disadvantages for different types. The main categories, as we just said in the previous chapter, we have the hydraulic valves. They're used for to control the direction, to control the pressure, and to control the flow. A big note here, any pressure, sorry, I keep saying pressure. Any hydraulic valve, actually, it would have all these three, regardless what the type or what the category is. If you have a valve, you're trying to control the flow, how much flow goes inside the line. So the main task or operation for that is to control the flow. But when you do this, it's going to create a pressure drop across that. And so not necessarily this one, but for example, the DCV, it's going also to control the direction of the flow. So although you might see some pressure drop, but the main task or the main reason you have a valve in that application is to control something else. For example, the pressure or the flow. For example, the direction, we have two main types. We have what we call the DCV, or the direction, from the name, directional control valve, DCV. It's used to control the direction. For example, if you're using this DCV inside this cylinder, you will need to change the position so that you direct the flow to go to the front or to the left side of the piston to push it. And then if it's hydraulic, then you need that fluid or oil to go back to the tank. So you will need to change the position of the DCV to go to the first position. Now, if you want to do retraction, then you should change the position to go to the third position. So that's 1, 2, 3. This would make the high pressure coming from the pump to go to the right side. As you can see on the red line here, it's going to push on the back side of the piston, and then it pushes the fluid. So the oil goes back from the left side. It goes back to the tank through the blue line, as we see, and then the piston would move from right to left. So you can keep jumping from position 1 to 3, 3 to 1, and so on, to keep doing that extension retraction phenomena. If at one point you needed to stop, but you don't want to turn off the pump, so you would go to position 2, and it's the dead end. Those are not connected, so the pump is still working. So it goes here, and then it goes back to the tank. This type is usually it has what we call the pressure relief valve, so that we control the system. In fact, any system, we would put a pressure relief valve, because we never know even if you have a variable displacement pump, which means as the load change, the output from the pump would change as well. So if it feels that we don't need that much pressure, or if we go to the neutral and it's blocked somehow, so it should sense the pressure, and this should go down all the way. But you never know. Maybe the response is not working, and the pump keeps pumping, the pressure builds up, and you cross the burst pressure of the pipe, and it bursts. That's why we need some kind of protection, and that's the second type when we will be talking about pressure relief valve and pressure reducing valve. So usually systems, we do need to have a pressure relief valve, and usually it should protect the system. So we put those valves, the pressure relief valve, next to the highest pressure point inside the system, which is the pump. That's where the highest pressure is. After that, you have pressure drop across the lines, across the valves, the DCV, for example, elbows, and so on. So pressure starts dropping as we move on. All right, before we move on, I don't know if I include also check valve, but that's something we already we're familiar with, and we discussed it. So Check valve, it allows the flow to go in one direction, and we'll go over that in more details, but not in this direction. Okay, so since it allows the movement in one direction, not in this direction, so it is classified under the directional uh, valves category. The second type, I just mentioned that, so we'll skip it. The pressure relief valve, it's the main uh, task or the main function for that valve is to control the maximum pressure and protect the system against bursting. So we will be discussing this type. We'll be discussing pressure reducing valve. We'll be discussing sequence valve and so on. And then after that, we will review or we will do what we did in that last part of the previous chapter, which is the flow control valve, the orifice and needle valve. Okay, so why we need pressure? We might finish a couple slides in this first part of this lecture. So almost in 1850s, most boats, they used to work on boilers, which are big pressure tanks. You boil water and then you have steam, which moves the engine. And from the name, they're called like as I said, it's pressure tanks. So they're tanks that are pressurized. They have really high pressure in order to move those big boats. And back in 1850s, I don't know before that what they used. Uh, did they have any kind of safety or not? Maybe they were happy about moving boats, but they didn't care, or they didn't have enough technology to add it, or they didn't see the need for that. Anyway, so they would have some explosions here and there, but almost in 1900, maybe before or after, they reached almost to 400 explosions. Just to give you an idea how bad an explosion could reach, or maybe more, maybe much less, I don't know. But in 1865, one explosion only resulted in 1,800 people dead. So you can multiply that by 400 to see why they started looking. And that's why you have this chart. It's showing you like the number of explosions started decreasing after that year, after 1900 or maybe 1950 and so on. But they started working on some safety measures, and you can see the big a steep reduction after that year. That's when they started including those pressure relief valves inside the system. So anytime something happens, the pressure goes all the way up. So you will have a relieving mechanism which relieves the pressure back into some other systems or into the atmosphere or to the tank, depending on what you're doing. The symbol, just as a reminder or a review, for pressure relief valve, it's a box that has a line or an arrow, and usually you have two lines. That's the upstream, that's the downstream. So that's the system line, and you have a dotted line which resembles it tells you that's the pressure sensing. It's sensing the pressure in that line. You for pressure relief valve, we sense the pressure of the upstream line. Because we have the pressure reducing valve, it senses the pressure of the line after the valve, not before. Okay, usually this type of valve, it's normally closed, which means it's not operating as long as you don't meet what we call the cracking pressure, which is the pressure needed to crack if it's spring loaded. Like you said here, this valve to open at 1500. So if you don't cross the 1500, it's not going to open, and no oil or no fluid or no flow would go through the valve into the output. Here, it's going to go back to the tank. As you can see, it's sensing the upstream, so it's sensing this pressure. If the system, for some reason, let's check here. If we don't have this one, you have the filter here. Over time, it's going to get clogged, correct? So the pump is working. This is a fixed displacement pump, which means it's as long as it's plugged in, you hit it to work, it's gonna deliver whatever pressure, like 20 GPM at a specific pressure is gonna deliver that. Well, the filter it got clogged at one point, so it stops delivering. So what would happen to this line is gonna burst. That's why we would provide a relieving mechanism here by providing this pressure relief valve. This line, dotted line, it's the pilot line or the sensing line for the pressure relief valve. It measures the flow or it measures the pressure. If it crosses this cracking pressure, is going to open. So when we say normally closed, that's why we see this arrow. It's not aligned. It means it's not aligned with the line, so it doesn't allow any movement. So it would start relieving the pressure. As an extra step to protect the system more, we add a bypass across the filter. Again, I don't need the oil to go through the bypass at any time. Just when a specific pressure is reached, when this filter gets clogged, it would start building pressure here. This PRV, which would be different than the setting pressure for the first one, once it's reached, so it opens and starts allowing the oil to go through it. It's good to add, for example, a sensor to sense that oil now is passing through this. So it gives you a yellow, red, green. I should color them, but it gives you a yellow alarm that the filter needs to be changed when the oil starts passing through the bypass, so that you would go and change the filter at one point. Okay, so I'll let you read through these. One more note to add is usually you can see you have the PRV and then you have this line, and that's usually if we have to consider the pressure drop across this line, because and that's called the drain line. So let's assume that the critical system pressure, the system would explode at 500 psi. And then you have the drain line. It's the pressure drop inside the drain line is 50 psi. If you just set the PRV here, the pressure relief valve, if you set it at 500 psi, so when the system is 500, when the system reaches 500 psi, what would happen? It senses the pressure relief valve. It senses that the system is 500. Yes, it opens, but the pressure in the system is 500. Here, the cracking pressure, so it cracks the valve or the spring to open, but you have an additional 50 and the drain line. So the flow can't go to the tank until what pressure? Until this pressure is 550. When this pressure is 550, we will overcome this pressure and this pressure. Well, we already crossed the critical system. So what pressure should we set the PRV at? It should be the critical minus the drain line. So we should set the drain valve at 450 psi. Okay, so for 450 and 50 in the drain line. So when the system reaches 450, this one opens, no flow yet. When it reaches 500, 450 to keep the PRV open and 50 to overcome the loss in the drain line. Keep in mind what? That the tank is open to the atmosphere. So if the tank is also pressurized, we should also include the pressure in the tank, because again, you need to push the flow through the valve, through the line, and into the tank. So you need to have enough pressure. You can't cross the 500, so you should deduct all these pressures from the set pressure for the PRV. Okay, this is called the direct pressure relief valve. We have some that are indirect, so it senses the pressure directly in the upstream line. This is just a sectional view for that. So you have this puppet, as you can see, it's curved at those two lines here and here. So in its normal position, it would be sitting on this base, so it's blocked. So that's the line pressure, that's the pressure before or upstream the valve. So we don't and that's the spring right here. So we set the spring at a specific force, which gives us enough pressure to keep the piston down. Now, the pressure inside that line is building up. What would happen? There is more and more pressure pushing since this is blocked, so nothing can go through. So it's going to start pushing down here and pushing on this area, not this one, just here and here, which is what you see here. We will call this the hydraulic force. That's the force coming from the hydraulic fluid. It's pushing up. When would this move up? When the hydraulic force is more than that set pressure, which is the spring pressure or the spring force. We do force analysis. So you have to be careful if there's any friction across these lines, you have to consider it. So once the hydraulic force is equal, it's not going to open, but anytime it crosses the spring force, the spool is lifted. And as you can see, the flow starts going through it into the tank. So it relieves the pressure and it stays there. Once that pressure goes down, so the force also goes down, and then the spring will start pushing the spool slightly down so you can control how much relief or how much oil is going back to the reservoir. Okay. Another example, that's what I was talking about when I mentioned the homework. I believe that was question number 2 in the homework. So you can control, you have a pump that feeds a hydraulic motor. That's a fixed displacement pump, so it's going to provide a specific flow and pressure. So if you want to decrease the speed of the motor, you would need, in this case, to add this needle valve. That needle valve, you can close it open to control how much flow goes into the motor, which in turn controls the hydraulic motor. If you need to, if you close it, let's say by mistake or something gets clogged, so this one is completely blocked. This is a fixed displacement pump, which would still provide some pressure. So pressure will start building up. So I need to provide a pressure relief valve whenever I put a needle valve and we have a fixed displacement pump. Although we don't need it with variable speed pumps like that, we don't need a pressure relief valve, but we would still provide it. So the question before we end this part, what is the cracking pressure of this relief valve? Depending on what you see on this chart. And we're going to do an example next time or in the next part of this chapter. So here we have the flow versus the pressure for the pressure relief valve. You can see the pressure is building up inside the valve, but still no flow. When do you start seeing flow going through the pressure? When you hit the 1500 psi. So what's the cracking pressure of the relief valve? It's 1500 psi. Okay. And when it starts opening, there's more and more pressure being built, and we're trying to keep it there. So there has to be more flow flowing through the PRV to make sure it's relieved, and we protect the system more and more. And the last example, this is just a direct one. So in normal operation, the pressure relief valve, we can see it. We're providing a flow to these two DCVs in normal operation, as long as when the P system is less than P crack of this pressure relief valve. So the flow would go to the right, as you can see in the orange lines, and then it goes back from the DCV or from each cylinder back through the DCV into the tank. When we cross that cracking pressure of the pressure relief valve, this time you're still providing flow to the two cylinders, cylinder 1 and 2. But since you crossed that cracking pressure, which means the pressure, there's something happening, which either the requirement for the load has decreased, or something is blocked. So this pressure relief valve opens, and now we have flow going through the pressure relief valve. You have the return from the two cylinders. They join this line. All of them, they go back to the tank. Okay. We'll stop here.